Lesson 5, Advanced Integration Techniques, Integration by Parts, Part 2. Example 1. Evaluate the integral between pi and 0 of x squared sine x dx. Now this is a bit more involved, this one, because it comes in two parts. So we'll set up the rule. That is the integral of u to v equals uv minus the integral of v du. Here my u is going to be x squared and my dv is going to be sine x. So my du equals 2x and my v is equal to minus cos x. So the integral is equal to, now it'll be uv, so it'll be minus x squared cos x between pi and 0 minus the integral of v du. So it's that one times that one, so I'll put a 2 at the front, change that to a plus cos x pi and 0. Oops, an x in there. Almost lost that x. Dx. Alright. Okay, just make sure, just check that carefully. So you don't make that mistake I almost did then. Okay, putting the values in. We're going to get here of minus pi squared. And the cos of pi is minus 1, so that's plus. And putting 0 in there, that's obviously going to give you 0. So it's just pi squared plus 2 integral pi naught x cos x dx. Okay, so now we have to go again. So we're going to work out the integral of x cos x dx. So let u equal x and v equals cos x. So du is equal to 1 and v equals, now the integral of cos x is sin x. So now my integral I, I'll call this I1 if you like, I1 is equal to uv x sin x between pi and 0 minus the integral between pi and naught of v du, which is just sin x dx. Okay, so when you integrate that, you'll get, well, when you put those values in, you'll get sin of pi is naught, so it'll be naught, and that'll be 0, so just 0, minus, now when you integrate sine, you get minus cos x between pi and 0. And that's, careful with these signs now, that's a little cos x now, between pi and 0. The cos of pi is minus 1, and the cos of 0 is minus 1, so that's negative 2. So our final answer, I, will be equal to pi squared from up here, plus 2 times this result. Whoops, there'll be minus 2 there. 2 times this result, which is minus 4, is your final answer. Example 2, evaluate the integral between the limits of pi upon 2 and 0 of e dx sin x dx. So writing out the rule, we have the integral of u dv equals uv minus the integral of v du. So this time I'm going to let u equals sin x and dv equals e dx. Now you could have done either way, but I prefer using e dx because integrating this is quite simple. Well, so is the other, I guess, but you're avoiding a negative sign. So now du equals cos x and v equals e to the x. So our integral equals uv e to the x sine x between pi upon 2 and 0 minus the integral of e to the x cos x dx between pi upon 2 and 0. Now this is e to the pi upon 2, and sine of pi upon 2 is 1. And of course, e to the 0 is 1, but the sine of the 0 is 0, so just e to the pi upon 2 minus this integral here. We'll call this one I1, and we'll call this one I2. So our original integral, this one here, we're going to call I1, right? Okay, so let's work out this integral. Again, doing the same sort of thing. Okay, oops. So our u equals cos x, and now dv equals e to the x. So now du equals minus sine x, and v equals e to the x. So that equals uv e to the x cos x between pi upon 2 and 0 minus the integral of v du, so it makes that a plus, e to the x sine x. So we got back to where we started from. Don't worry about that. It's a way of dealing with it. Now remember what I said, I'm going to call that I1, so I'll call that I1 in there. First we'll work this out. Now that's e to the pi upon 2, but the cos of pi upon 2 is 0, so that's 0. So it's 0 minus e to the 0 is 1, so it's minus 1 plus I1. Okay? So going back into this one here, we'll say that I1, the one we're after, equals e to the pi upon 2 minus 1 plus I1, and that's equal to e to the pi upon 2 plus 1 minus I1. So take this across and we get 2I1 equals e to the pi upon 2 plus 1, and that gives me that our original integral is equal to 1/2 of e to the pi upon 2 plus 1.